Hey guys, thank you so much for joining in and welcome back to the live session with Manifold AI Learning. So, folks, the topic of today's discussion is one of the most important, I would say, technique that we have got in machine learning, that is ensemble learning. Now, we already had a high level introduction in the last session. So, in the last session, when we discussed about the dictionary, so we have seen what exactly is this ensemble learning at a very high level. Now, as we progress in today's session, we will be discussing in depth about what is this ensemble learning technique, what is the idea behind this ensemble learning technique, and how we can get the most of this ensemble learning technique. I'll also give you the mathematical insights as how the pattern will be learned in a given data set. So that would be the agenda of today's session, guys. Now, to get the access to our previous sessions recording as well as the code, so here, what you can do is go to our site, manifoldailearning.in, click on courses, and under the courses, if you come down in the same page, there's a course on hands-on machine learning, Keras, Scikit-Learn, TensorFlow. So you can click on this button that says as access the learning content now, and you'll be able to access all the sessions recording as well as the code file that we have generated as we progress in our learning journey so far. Okay, go ahead and register yourself. I'll share the link over here in the chat window as well. So use this link and sign up on the website so that you can get the access to the course content that we have got. And we've also shared these links in the course description as well so that you can go ahead and access it. Now I've got a question for you guys. So before I describe about this ensemble learning, I want to know from you, what do you understand about the ensemble learning? So what's your understanding about this ensemble learning team? So please let me know. So what's your understanding about the ensemble learning? And like it's fine, even if it's wrong as well. Just I want to know from your perspective, your current understanding so far. Okay, Lakshman says I'll be using multiple machine learning models in case of ensemble learning. Okay, that's great. How about others? Samiksha says we using multiple models to predict the best, okay, to learn the complex relationship. Yeah, that's also correct, Samiksha. Okay, Dheeraj. Yeah, that's also correct. Dheeraj says that it's a technique where we make use of multiple machine learning models and uh, perform the fit on this data set so that we can identify the hidden insights in a large data set using multiple models. Okay, that's correct. That's correct, guys. And thank you so much for all of your answers. So I can say all of you are correct. So let me just give you an overall idea as what exactly is this ensemble learning. So as most of you have discussed or mentioned over here, so ensemble learning is a technique where we want to learn the complex pattern in a given data set using multiple machine learning models. Now, if I make use of a single machine learning model, let's consider the decision tree algorithm, which we have discussed very recently. So if I consider this example model of decision tree, what happens is if I make use of this decision tree model and let's say if I perform the fit on that given data set, one challenge that we would observe is the overfitting. So we would observe that there will be overfitting that could happen on this given data set. And because of that overfitting, we'll be unable to find the like the best possible pattern in the given data. I mean, we'll not be able to generalize the uh, will not be able to generalize in an efficient way on the unknown data. So that's one of the common challenge that we get to have in case of decision tree. Now, if you consider a simple model, let's say the linear regression or the logistic regression model, these models are very simple in nature, and these simple models will struggle to identify the complex patterns in the data set. So we'll be having the issues of overfitting if I'm making use of the models like the decision tree, and we will have the issues of underfit when I'm making use of the simple model. Now, that's a common challenge that we get to face whenever we are implementing the machine learning on a given data set. The solution is instead of using a single model like a dictionary model, we'll be making use of multiple weak learners so that together we'll be able to achieve the best possible outcome for the given data set, or we'll be able to find the best possible pattern for the given data set. Okay, so that is the overall idea about this ensemble learning. Now, here in this ensemble learning technique, so there are various techniques that we have got in this ensemble learning technique. Let me list down the first. So when we talk about the ensemble learning, so there are various techniques that we have got under this ensemble learning. We have the oating technique, we have bagging technique, and we have boosting technique, and we also have another technique called stacking. So these are all the common techniques that we have got inside this ensemble learning technique. Now let's understand each of them in a high level, and then we can look into its practical implementation. If I consider the voting technique, so in the case of this voting technique, what we'll do is we'll make use of multiple machine learning models. Okay, let's say model 1, model 2, model 3. And each model can be of its own class. Like for example, let's say this is the logistic regression, this is my decision tree, and this is my SVM. So I have three different models with me. Now, what we'll do is in the case of voting classifiers, we'll have a training data set and we will provide this complete training data for each of the models. And we'll perform the training on each of the model on the single training data. Now, once the training is completed, the next thing that we are going to do is we'll get a new data. So this is the new data where I want to generate the prediction. So I'll be sending this new data to all the models that we have got, that is model 1, model 2, model 3. And then once I've sent in this data for all the three model, I'll be generating the prediction. Okay, I would go ahead and generate the prediction. Now, let's say I'll be getting the prediction as 0, 0, 1. Okay, these are the predictions that I've got from model 1, model 2, and model 3 respectively. Now, in this case, when we have the prediction of 0, 0, 1, so at the end, in order to determine what is the overall prediction for this new data, I'm going to perform the activity of aggregation. I'll perform the activity of aggregation where I'll see how many number of uh, models is giving me the output as the class 0. And I'll also see how many number of models that I'm getting the output as class 1. So here in this case for class 0, I've got 2 votes, and for class 1, I've got 1 votes after the aggregation. So since for class 0, we are having the highest number of votes, the overall prediction for this new data will be class 0. Okay, this is how we are going to generate the prediction in the case of voting classifier. I'm going to train multiple machine learning models. And once I train my multiple machine learning models while generating the prediction, I'll take the votes. I'll take the votes, and whichever is the one that is returning the maximum number of votes, I mean, the class that I'm getting, that is the classification that I'm going to assign for the new data. And that's the overall idea behind this voting classifier. Okay, team. So is this clear to every one of you? So team, if you're clear, please confirm by typing in as all good. Rakshit, Ram, okay, uh, Sangeeta, Dakshayani. Okay, excellent, guys. Thank you so much, team, for confirming. Okay, now that this concept is clear, Now let's see how we can actually implement it. See, if I want to implement this voting classifier, so we'll be making use of the voting classifier class from the Scikit-Learn. So this is basically a Scikit-Learn ensemble voting classifier. So we import this voting classifier from scikit-learn.ensemble, and here we would have to send in the list of estimators that we want to use. Okay, here we'll be sending the list of estimators, like whatever the other estimators that I want to use it for performing the training and the prediction. So we would go ahead and mention these estimators, and this is sent in the format of list of tuples. Now inside the tuple, so we basically have two things. One is the name, the other one is the estimator itself. So we would mention both of them, and we'll be specifying under this estimator. And this is followed by voting. Here we'll have to mention what kind of voting that we want to perform. So here in the previous example that I've explained, so the example that I explained was for the hard voting, where I'll be looking at the absolute prediction from the model, and based on that, we'll be generating the prediction. Now that's called as the hard voting. And we also have another kind of voting that's called as soft voting. Now, in the case of the soft voting, so what we do is we'll consider the probability score. So we'll consider the probability score, and based on the probability score, we would go ahead and determine the overall prediction from the given data set. So this is the overall idea about working with this ensemble model of this voting classifier. Now let's go ahead and implement this ensemble learning for a given data set so that we'll get a better understanding as how it actually works. So I'll start by creating a new notebook. Here I'll say new notebook, and for the demonstration purpose, we'll get some data set. Okay, so I'll do one thing. Here, to get started, I'll start by importing the necessary libraries and the classes. So from sklearn.ensemble, I'm going to import the voting classifier. Okay. Now, apart from that, I'm also going to import few more things. I'll say from sklearn.linear underscore model, I'm going to import a logistic regression, assuming that I'm working with the classification task. And I'm going to import, let's say, Gauss, the naive Bayes model as well. Okay, sklearn.naive Bayes. I'm also going to import the Gaussian NB. Okay, and let me import the support vector classifier as well. From sklearn.svm, I'm going to import svc. Now, apart from that, let me import the NumPy library, which will be helping for me to generate some random data. So once this is done, here, in this case of voting classifier, so we'll be using the multiple models. So I'll create a model, I'll call as M1. Okay. And for this M1, I'm going to mention as logistic regression. In the same way, I'll be creating my M2. Okay. So here I'm going to instantiate it as the Gaussian NP. Then we'll create my M3. So N3 is, let me say, SVC. Okay. I'm making use of default values of the hyperparameters. Now, once I have defined three models, the next thing that we will do is we would go ahead and create the estimators, and I'm going to create it as a list. And inside this list, I'll be specifying the tuple. So the first tuple will have the model name. So the model name, I'm going to call it as logistic, and the model is M1. Okay. The second model is Gaussian, and I'll say M2. And for the third model name, I'll mention as SVM, and it is M3. Now, let's start by initializing a data set. So for the demonstration purpose, I'll be initializing my X and Y in this manner. So I will initialize my X and Y in this manner, where I've got the X, where it's basically the each row has got two rows, two columns. That's what we have got. That means I've got two features and I have the respective target in Y. So I would go ahead and build my voting classifier. I'll say voting is equal to voting classifier. And then here inside this voting classifier, I'm going to mention my estimators is equal to estimators, the one that I've created earlier. Then we can specify the voting. So in this case, I'll mention my voting as hard voting. Okay, now once we initialize this, next, obviously, it is performing the fit on this given data set. We can perform the fit, and then we can go ahead and generate the prediction. I'll simply say voting dot predict. Since it's a very small data, I'll just go ahead and predict right below it. So this would go ahead and generate the prediction for us. Okay, so X comma Y. See, we've got the prediction from the model, and if you take a look at it, 111,222, which is matching our expected values. Okay. Now, instead, if I do not want to use the hard voting, I can also make use of the soft voting as well. I can also make use of this soft voting. Okay. The one thing is, uh, when if I'm using the SVC, I'll have to say probability is equal to true. See, if I make use of the soft voting, so I'll just have to ensure that the model that I'm working is able to generate the predict probabilities. And based on that, we can make use of the soft voting as well. All right, guys. So this is about the voting classifier and how it can be applied for a given data set. So any questions so far, folks, on this voting classifier? Okay. Thank you, Lakshmi. Thank you, Samir. Okay. Thank you, Darshan. Great. Okay, guys. So, team, I just want to take a moment to give you some more information about Manifold AI Learning. So, Manifold AI Learning is a e-learning company who's into providing the high quality, affordable education on the various in-demand topics like machine learning, deep learning, ML ops, LLM ops, and so on. So, you can check out their courses at manifoldailearning.in. So one most in-demand course, it's about NVIDIA Certified Associate Generative AI LLM NCA General Certification Examination. If you're someone who is planning to attend and take the NVIDIA certification, I highly recommend you to check out this course. This is a early release course. So there's already two sections have been already completed, which is having more than 9.5 hours of content, and the further content will be added as and when the progression will be done in progress. So you can go ahead and join the course and get started with your learning journey for your NVIDIA certification. Now, apart from this course, and like we'll also be launching the practice questions as well for you to get a practice questions for these NVIDIA certification. Now, if you don't want to purchase separately, you can go ahead and enroll it on the Manifold AI Learning Mastering the Generative AI package. Now, by enrolling into this single package, you get to have all course access for various courses that will be published under the heading of Generative AI, which includes the NVIDIA certification that I've talked about, along with the practice questions that we'll be adding. And it already includes more than 14 courses. You can check out the course page where you can just have to purchase once, and you'll be able to get the access for all the courses from Manifold AI Learning in the generative AI space in future upgrades for free. Okay, so I'll be sharing you the link over here in the description. Do check out the Manifold AI Learning page, and there's a limited time offer that's going on. By making use of the coupon code of Gen AI 5, you can also avail 5% off on the prices that you see right now. Okay, do check out the course page for more information, and for any help, you can raise a ticket over here through this Manifold AI Learning portal, or drop an email to support@manifoldailearning.in. Okay, now coming back to our learning journey. So, folks, I'll take a pause here. Do you have, if you have got any questions on the topic of this voting classifier, please do let me know. Okay, thank you, Sridhar. Okay, I'm glad, Varshini, that you are able to follow along. Okay, now let's progress. Now, you have learned about one of the technique in the ensemble learning, that's the voting classifier. Now, let's understand the next topic that we have got in the ensemble learning, that is the bagging classifier. See, when we talk about this bagging classifier, it's a machine learning model that we have got, where it makes use of multiple models. And while working with the data set, we will have the bagging method, which is known as the bootstrap sampling method, that would happen on our training data set. And while generating the prediction, we will make use of the aggregation. So that's the idea about this bagging classifier. So let's get some more intuition behind this bagging classifier. So here, when we talk about this bagging classifier, so suppose if I've got a data set, okay, let's say I have 10 columns and 1000 rows. So here, what we do is we'll perform the sample selection with replacement, and we are going to generate the samples. So for example purpose, I would say that I'm going to generate 10 samples. Each sample will contain 500 rows and let's say 7 columns. So I'm going to generate my sample 1, which is having 500 rows and 7 columns. Sample 2, like this, I'll have S3, S4, S5, S6, S7. So 500 rows and 7 column. Now, the best part is when we say sample selection with replacement, here from my entire data set, okay, from the entire data set, we are going to select the samples. We are going to select the samples in a in a way where I'm going to select the sample and I'm going to replace it. Okay, I would go ahead and replace it back into my uh, like I'll select the samples and I'll replace it back into my population. So I'll repeat this activity for all the 7 samples that I've got. So hence we call this as sample selection with replacement step. Now, once I've generated these samples we call it as bootstrap samples. Okay, we call it as the bootstrap sample. So here, uh, it's like we'll perform the selection of samples with replacement. And once I've generated the samples with replacement, for each and every sample, I'm going to train the machine learning model. Let's say decision tree 1, decision tree 2, up to decision tree 7. So one thing that you have to remember is in the case of this bagging model, all models should be of same class. So all models should be of same class, DT1, DT2, DT3 up to DTN. So like we expect that all models should be of same class. Okay, let's say if it is decision tree, I should be having 7 decision tree. If it is the logistic regression, I like in this case, I should be having all of the models should be belonging to the logistic regression. So the idea is the all the models should be of same class. Now once I've got the models of the same class, okay, on each of the sample that we have generated, we would go ahead and perform the training. Okay, we would go ahead and perform the training. Now, once we perform the training on each of the sample that has been generated, the next thing that we will do is, okay, when we have a new data set, we will send this new data set for each of the model that we have generated. And finally, we'll take the aggregation. So the aggregation is very much similar to the voting classifier that we have seen earlier. So we'll perform the aggregation on this given data set. So this is called as bootstrap plus aggregation technique, which is also known as the bagging technique. So the bagging comes under the ensemble learning technique, where we generate the multiple samples, and these samples are generated with replacement. Okay, so that's the overall idea about this. The second technique that we have got, that is bagging technique. Now, when we are applying this bagging technique, and if I make use of the addition tree, so this bagging with addition tree is also known as the random forest algorithm. Okay, so this was about the ensemble learning technique, which is the bagging classifier. So is this concept is clear, folks? So is this clear now? Lakshmikant, Samyukta, okay, Padma, Anna, Pradeep, Subir. Okay, thank you, team, for confirming. So, team, if you have got any questions, please feel free to let me know. Okay, so now that you have learned about this concept of bagging classifier, let's see how we can actually implement this bagging classifier. See, if we want to implement this bagging classifier, we can import the bagging classifier from sklearn.ensemble, and then we'll just have to mention the number of estimator and the estimator type that we want to use, whether it is logical regression or addition tree or whatever the model. Okay, I'll just have to mention the model for the estimator, the number of estimators, that is number of such models that I want to train. So uh, uh, that is present right here. Okay, so that is present over here, that is number of estimators. And we also have uh, the uh, maximum samples. Here the maximum samples is nothing but like what is the total number of samples that we have to consider. So which means whether we want to perform the sample selection across the rows or not. Okay, so the maximum samples will help us to decide whether we want to perform the sample selection along the rows. And we have the maximum features over here on the maximum features. So it basically helps us to control whether we want to perform the sample selection across the columns. So these are the two things that we would specify whenever we are implementing this bagging classifier. So we can mention it according to our requirement. Okay. Now, apart from this, we can also mention bootstrap is equal to true to clearly mention whether the sample selection with replacement is allowed or not. So that's the basic idea of implementing this bagging classifier, folks. So here, let me start by demonstrating the same. Here, I'm going to mention the heading as bagging classifier. So just for the demonstration purpose, so here, I'll just copy and paste it here. Okay. I'll just import the ones that is necessary for me. So for instead of voting classifier, I'm going to mention as bagging classifier. Okay. I'll just mention as the bagging classifier. Now, apart from this bagging classifier, we'll just require the data. Maybe we'll make use of the same X and Y that we have generated earlier. Now, we can make use of the, let's say, logistic regression itself, okay, just for the demonstration purpose. So here I'm going to instantiate a model. I'll say M1 is equal to logistic regression, and then I'm going to call the bagging classifier. I'll say bag is equal to bagging classifier, and here I'm going to mention my number of samples. I'll say 0.8, and number of features, it's actually max samples, okay, and max features as, let's say, 0.7. I want to have 70% of data, okay, and we'll also say the estimator, okay, we have actually missed it. So estimator is equal to M1. That's the model that I want to use, and number of estimators I'm going to mention as 50. So I'll be training 50 such models on this given data set. Okay, this is how I would specify the model configuration. Then I can simply say bag.fit x comma y, and then we can go ahead and generate the prediction. So this would help me to generate the prediction. So that is the very simplest way of demonstrating the usage of this bagging classifier. So in this bagging classifier approach, so we would go ahead and instantiate the multiple machine learning models. Here in this case, we have understood that we need to have the multiple models, and all these models should be of same class, just like we have implemented just now. And we can we can perform the sample selection with replacement. That is, we can generate the bootstrap samples, and we can specify the estimator, number of estimators, and so on. So that's the overall idea about this bagging classifier technique. Okay, team, any questions on this bagging classifier technique? Do you have any questions, folks? Thank you, Mariam. Okay, thank you, Amit. Thank you, Anusha. Thank you, Nandish. How about others? Any other questions? Okay, thank you, Lakshmi. Perfect, guys. Thank you so much, team, for confirming. Okay, next, let's proceed ahead and let's look into the another technique. I think we have learned one more thing that's called as random forest. So let's implement the random forest as well. So instead of bagging classifier, I'm going to say random forest classifier. Okay, and I'm going to say M2 is equal to, I'll just say RF, okay? RF is equal to random forest classifier. Now, in case of my random forest classifier, so the important thing that you have to note down is, since the random forest classifier utilizes the decision tree algorithm by default. So if you take a look into the hyperparameters of this random forest classifier, we'll have the number of estimators, the criterion, maximum depth, minimum sample leaf. So all these information that you see right here, okay, these are all relevant to our decision tree algorithm. So you can say bagging classifier with the decision tree is actually the random forest classifier. Okay, so for this random forest classifier, I'm going to say number of estimators as 100, and I'll keep the remaining settings as it is. Rf.fit x comma y and rf.predict, okay, x comma y. Rf.predict x. Okay, so this will help me to generate the prediction. So this is about the random forest classifier. So what you have learned so far is, you have learned about the voting classifier, bagging classifier, and the random forest classifier. And the last one that we have got under this ensemble learning is the boosting technique. See, in the case of this boosting, what happens is, here you'll be training multiple machine learning models. You'll train multiple machine learning models, but this time you'll be training them in a sequence. You'll be training those machine learning models in a sequence so that at the end, as an overall, you'll be getting the better performing model. First, you will train, let's say, the first machine learning model you'll train, and whatever the mistakes that is being made by M1, you'll correct it with the help of M2, and you'll correct it with the help of M3, and so on and so forth. So you will be training the models in a sequential manner so that you can minimize the error and you can understand the pattern in a much more in-depth way as and when you go deeper in this training. So that's the high level intuition behind this boosting technique. Now, under this boosting, we have two types of technique. One is add a boost technique, and the other one is called as gradient boosting technique. Now, in case of add a boost, this is also known as the adaptive boosting technique. Here in this case, what you would do is like you will go ahead and assign the weights for each and every row on your given data set. And once you assign the weights, depending on whether it's a right prediction or wrong prediction from the given model, you would go ahead and adjust the weights as the training proceeds. Okay, that's the overall idea behind this boosting technique. And more importantly, the add a boost technique. And here in the case of gradient boosting, what you will do is you will try to fit your loss function or the loss value. You'll try to fit your loss value with your prediction. Okay. You'll try to fit your loss value, that is the error width, the target as and when you progress in your training. So that's the idea behind this gradient boosting technique. So these are the two common techniques that we generally deal with when we are working with the boosting technique. So let's go ahead and implement each of this boosting technique, that is add a boost and the gradient boosting technique. So to start with, I would mention as add a boost. So here I'm going to say from sklearn.ensemble, import add a boost classifier. I'm going to say add a boost dot fit x comma y. And here, when we are talking about this add a boost classifier, even though it will be trained in a sequence, here we'll also have the ability to mention what is the base model that I want to use, that is a weak model that I want to use under this estimator, and we have to specify the number of estimators. So these are the two things that we have to mention whenever we are performing the training. If I don't mention anything for the estimator, it will consider the decision tree with depth as 1 and the number of estimators is 50. So we'll instantiate the model and we can perform the fit, and then we can go ahead and generate the prediction. Similarly, we can implement the gradient boosting as well. Gradient boost and classifier. Okay, so I'll say grad is equal to grad dot fit x comma y, and then grad dot predict x. This would help me to generate the prediction for this given data. So this is about the gradient boosting classifier. So the way it works is uh, completely similar to what we have seen, like what we have understood. That means it will perform the fit with reference to the loss value. Okay, so this would refer to the uh, loss value that we have got. Okay, so that's the overall idea here, team. So like we have got the gradient boosting classifier and we'll perform the fit. Okay, now apart from this gradient boosting classifier, there's one more that's called as like there's one more which is a most common one that's called as the XGBoost. Now this XGBoost that we have got, think of it as a optimized version of the gradient boosting. So this is an optimized version of gradient boosting. The best part is like when you're making use of this XGBoost, because of the variations and because of the optimization that they have done, you'll be able to experience the faster training time. And along with that, this also supports the machine learning on GPU, which will enhance the performance of this machine learning model during the prediction as well as the training as well. Okay, so that's the overall idea of this various ensemble learning model techniques, that is voting classifier, Bayesian classifier, random forest, and boosting models. All right, guys. So any questions so far? Do you have any questions on any of the topics that we have discussed so far? Please let me know. If you're clear, please let me know in the chat window. Okay, I see a question I've joined just now. How can I access the recording? Okay, so team, as I mentioned, in order to access the recording, go to the Manifold AI Learning.in, click on courses, and over here, just come down. And at the end, you'll be able to see the hands-on machine learning book series. So over here, click on access the content now. And using this page, you can access the recording of the session as well as the source code. All right, guys, I'll do one thing. Let me attach this notebook on the same portal, which I've just shown you. Okay, I've made the attachment on our page of hands-on machine learning. Please have a look into the same and you should be able to access the source code. Now, as I mentioned, you'll be able to access the session's recording once the session is completed. Okay, guys, so this was about the ensemble learning. Now, if you have got any question, please feel free to let me know. And team, if you're enjoying the session and if you're able to follow along with me, I'm sure you would enjoy the courses from Manifold AI Learning too. There are two courses that I would highly recommend if you're someone who's starting out in the machine learning. One is MLOps Bootcamp, and the other one is LLM Ops Bootcamp. So in this MLOps Bootcamp, you're going to learn anything and everything that is required for you to know about the machine learning operation, which includes the concepts such as version management with Git, the Python fundamentals, Docker, Fast API, Streamlit, Flask library, Linux, Jenkins, monitoring and debugging the machine learning system, continuous monitoring, deploying the application, and even the monitoring the overall applications, including the infrastructure as well. And this is a complete bootcamp which has got more than 35 hours of learning content. I highly recommend you to check out the course and get started with your learning journey. And the other course that I would recommend is the LLM Ops Masterclass, where you will be learning how you can make use of the large language models from OpenAI and build your own application and build the CI/CD pipeline around it. This includes the topics such as prompt engineering, the how to build the applications using the chat GPT, deploying the containers using the Kubernetes, which means you'll be learning the topics of Kubernetes. Even though you might be new to the Kubernetes, we'll take you through the enough basics so that you can follow along, learn the Kubernetes first, and then deploy the applications. This is a step-by-step guide. There are two projects that are part of your learning journey, which will help you to master the LLM operation. As I mentioned, you can also check out the other courses by registering the generative AI package. You get the access for most of the content from Manifold AI Learning so that you don't have to purchase again on the topic of generative AI, including the current topics as well as the future releases. Okay, I'll be sharing the links over here in the chat window. So do check out the same. And again, thank you so much, guys, for taking your time and joining with me on your on your weekend joining with me on this session. It was a pleasure to interact with each and every one of you. So thank you so much again, everyone. And if you have got any question, please feel free to let me know. So if you're clear, please confirm by typing in as all good. And I look forward to seeing you next time. Okay, I'll be there on the call for another 2 to 3 minutes in case if anyone has any queries. And if you do not have any queries, please feel free to drop. So thank you so much again, team. Okay, I see Nandini says, can I join? Oh, sure, Nandini. Yeah, you can feel free to join. I'll be there on the call in case if you have got any question. And we also have the admission team as well. Okay, any other questions, team, before I end the session? Okay, thank you so much, guys. And I look forward to seeing you next time. Take care.